Okay, good morning. So today I'm doing the lesson on the absolute value function. It's the first function in the function families that I'm going to be teaching you after parabola. That's the main function that we've worked on so far. So with a parabola, you know how to translate it, slide it, how to reflect it, flip it, and how to dilate, make wider or narrower. So we're basically going to be doing all of those things in one lesson with a new function. And each time I present a lesson, I'm going to add another function. So today, I'm only going to concentrate on absolute value. So the equation for absolute value looks like this. And this is actually considered what's called the parent function for absolute value. So it looks like y equals the absolute value of x. And that goes with this table here. So if I actually graphed it, it would be negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3, etc. Okay, so it kind of looks like a parabola, but not as curvy. So it's actually a V. So it goes like this, and it keeps going, and it goes like this, and it keeps going. And we're going to call this y equals the absolute value of x. Okay, so to get the absolute value on your calculator, so we just want to show you how to do this, is that you're going to plug in. So we're going to graph it on our calculator and just sort of look at it. So under y equals, you're going to clear out anything that you have on there, and you're going to go up to y1, and to get the absolute value function, you're going to hit the math key, which is below the green alpha key, and then you're going to hit the num right arrow over to where it says num. Right now it's at math, so go to num, and the first one says abs. That stands for absolute value, so hit the 1. And now you have an absolute value bar with your cursor flashing in it, and you're just going to put an X right in the center of that, and then right arrow out of that. So currently it says y1 equals the absolute value of x, and you're just going to hit a graph button. And it should hopefully look exactly like what you have there, but it's blue and mine's red. Okay, so let's answer some of the questions. So let's start with the vertex. The vertex is, again, the same as what we have with the parabola, kind of where it changes direction, and in this case, it's still 0, 0. Are there restrictions on the domain? Domain is x, and the answer is no. If you look from left to right on your graph, the x values go from negative infinity to positive infinity. Are there restrictions on the range? I'm going to say yes, because if you look at this, y is never negative. So therefore, I can write this two ways. I can write y is greater than or equal to 0, which I'm totally fine with. Or if you want to write it this way, you can write 0 is less than or equal to y, which is less than, no equal to. Oops, hold on. Which is less than infinity. So I'm good with the top one, y is greater than or equal to 0, but if you like to write it the bottom way, that's fine too. These two actually mean the same exact thing. Okay, so that's the parent function for absolute value, and basically what we're going to do right now is we're going to do all the different things that you and I did with parabolas. We're going to do them with this. Let's head to the next page. So absolute value is the distance from 0. Hint, the distance is always positive, which y, when you graph it, it's only in the first and the second quadrants. The absolute value of 8 is 8, and the absolute value of negative 8 is positive 8. What are the key features about the absolute value graph? So I'm going to just circle these, if you're okay with that. It has a vertex. It's an increasing function from x is greater than 0, it's increasing. When x is less than 0, it is a decreasing function. Does it have a constant rate of change? No. The only function that we know that has a constant rate of change, I'm hoping you're all saying to yourself, is linear. The line does not have a constant rate of change. All right, so let's try and play around with some of these graphs. So we're going to graph the following continuous functions. If it's continuous, it means it's going to be connected. Hopefully you remember that. And we will see what these look like, okay? So let's start with f of x equals the absolute value of x plus 3. So let's plug that in our calculator. Let's plug in y equals, and we currently have in there the absolute value of x. So let's right arrow past it and hit a plus 3. And then let's hit second graph to generate a table. So we have some values to look at. So I'm going to start with, I'm going to look for where the vertex is. You can actually find the vertex. The vertex is at 0, 3. So I'm going to go there, 1, 2, 3, and I'm going to put a dot. And then if I look, it's negative 1, 4, and 1, 4. And 2, 5, negative 2, 5, 3, 6, yep, 3, 6, negative 3, 6, 1, 2, 3. Okay, so I'm going to connect this. I have enough dots here to make this graph, and I'm going to call this f of x. G of x is in green, so I'm going to change my color. Okay. So g of x is equal to the absolute value of x minus 3. So I'm going to hit y equals on my calculator. Instead of retyping this, I'm just going to scroll over until cursor's on top of the plus. I'm going to make it a minus. And then I'm going to hit second graph. I'm going to generate a table that way. Okay, and I'm going to look for my vertex. I have to scroll down a little bit to find my vertex. So my vertex is at 0, negative 3. We're going to talk a little bit more about that in a minute. So then we have negative 1, negative 2, 1, negative 2, 2, negative 1, negative 2, negative 1, 3, 0, negative 3, 0. So we have enough dots here. And we're going to write g of x. Okay, so let's talk about this for a minute. So let's go back to what we know. Okay, we know that inside lies and outside tells the truth. Okay, so there's nothing for f of x inside the absolute value. We're going to, instead of looking at parentheses, now we're looking at so inside the absolute value, there is no value next to that x. So that's really like a 0. And outside is a plus 3. So if you look at this, the vertex for the red function is at 0, 3. So inside lies, outside tells the truth. So 0, 3 is the vertex for this. So let's write that down. While I'm thinking about it, though, let's take a look at the green function over here. The vertex here, inside lies, there's nothing here, it's 0. Outside tells the truth, 0, negative 3. There it is. Okay. You can also think about a slide for a minute. The parent function runs right through the origin. I'm going to draw the parent function in black. Okay, this would be the parent function that we drew on the prior page. Does that make sense? And if I look at the parent function and it has a plus 3 over here, that's telling me that there is a vertical shift because it's outside the absolute value and it went up 3. That is true. This over here tells me that this is also a vertical shift, but since it's minus 3, it went down 3. Okay, so the same rules that applied to parabolas when they were in vertex form apply here with the absolute value function. So what is the average rate of f of x change over the interval of negative 2 and 0? Okay, so we know how to find AROC. We're just going to make a little table, and we're going to have negative 2, and we're going to have 0, and we're going to come up with, we're looking at the f of x. So for f of x at negative 2, that is my red function. I got, it was negative 2, 5. And for 0, it was at 3. So we're going to calculate the change. This went up by 2. This went down by 2. So we're going to do y over x. Negative 2 over 2, and I got an answer of negative 1. What is the average rate of change of f of x over the interval from 0 to 2. Okay, so I'm going to create a table. I'm going to do that down here though. So I'm going to have 0 and 2. At 0, I have 3. And at 2, I got 5. So this one's going up by 2. This one's going up by 2. I'm going to get 2 over 2, which is equal to 1. Is there a constant rate of change? No. We talked about that earlier. This one says -1, this one says 1. So the only thing that has a constant rate of change is linear lines. So it says, so therefore absolute values do not have slope. It's very true. They do not have a slope. Identify the vertex of g of x. That's where it's 0, -3. Here's the Desmos link. I'm going to attach it in my Google Classroom so that you can actually play around with it if you would like to. That's totally up to you. Let's head to the next slide. Example number 2. So this time, if you take a look at this, you see the +3 and the -3, they are now inside the absolute value. So that's a little different than what you and I were just doing. So we will use our calculator. We will plug in y equals, and I am going to edit what I have in here, and I'm going to put my +3 inside my absolute value bar, and I'm going to delete out everything that's outside of it. And I'm going to hit second graph and generate a table. And I'm looking at my table and I see that the vertex is at -3, 0. So I'm going to go there. 1, 2, 3, -3, 0. And then I have -4, 1, -2, 1. So I don't know if you realize this, but the absolute value function is exactly the same once you've graphed the vertex. It's basically going up 1, right 1, up 1 each time, right 1, up 1, or left 1, up 1. So it looks pretty much exactly the same right now. I'm going to call this h of x. I'm then going to graph my f of x, which says y equals, and then x -3 in parentheses. So let's do that. I'm going to use my calculator and I'm going to edit what I already have there. I'm going to generate a table. And I have to scroll down to look for my vertex. My vertex is actually at 3, 0. We'll talk about what that means in a minute. And again, it goes up by 1s in each direction. Again, your graph is going to look much better than mine since my stylus is scary. Okay, what is the vertex of h of x? So h of x, the vertex was 0, -3. The vertex of f of x was at 0, I'm sorry, totally did that wrong. Don't listen to me. I'm going to erase everything. Okay. So the vertex of h of x is at -3, 0. I did it backwards. The vertex of f of x is at 3, 0. So let's talk about what's happening about the shifting. Okay, so again, I'll draw it in black. The parent function of absolute value starts at 0, 0, and it goes there. Let's talk about the red function compared to the black, compared to the parent function. So what's happening with the red function? The red function is shifting 3 units to the left. Let's take a look here. What do you notice? Okay, it says +3. So what do we remember? How does we shift absolute value functions vertically? Outside constants control the up or down movement. So the outside would tell the truth. That was in the prior slide. So I'm going to go backwards for a second. The outside, let's go back here. So here they were outside and it told the truth. So here when it was +3, we went up 3. When we had a -3, it went down 3. So that tells the truth. Well, how do the shift absolute value functions horizontally? So the inside lies. The inside tells me, so if I look here, if it said +3, look at my red function, it went left 3. So it's opposite x, same y. Here it said -3, and again, inside lies. If you look at my green function, it went to the right 3. So it is exactly the same as the way that we did it with the parabola. The parabola just had parentheses. This has an absolute value symbol around it. All right, let's check out the next slide. Example number 3. So first we're going to graph g of x, which is actually done for us already. Then we're going to graph f of x, which is equal to the absolute value of x minus 1 minus 5. So we can do this a lot of different ways. One, we could plug this in our calculator and generate some points. Or we could really think about this for a minute, okay? So the vertex of g of x is 0, 0. The vertex of f of x. So if I look at the vertex in here, do you know what the vertex is? If I said inside lies and outside tells the truth. So inside lies would be +1, outside tells the truth, -5. So I'm going to head to 1, -5. So I go right 1, 1, 2, 3, 4, down 5, and I'm going to put a dot. And again, the absolute value just goes up 1, right 1, or left 1, up 1. And I'm going to draw my new function, f of x. The question says describe how it shifted. There was a horizontal shift. I agree. It went right 1. There was a vertical shift, which meant it went down 5. So let's talk about that for a minute. Right 1, inside lies, down 5, outside tells the truth. All right, let's try the next one. So again, we have g of x equals the absolute value of x. There's my parent function for absolute value. It goes right through the origin. And then it wants us to do r of x, which is equal to 2 absolute value of x minus 1 plus 4. All right, so this one's a little more tricky just because it's got this 2 in front of it. So let's talk about the vertex for a minute. Do we know the vertex of r of x? We absolutely do, because we can look at the concept here of inside lies and outside tells the truth. So it's going to be 1, 4. So we're going to head right 1 and up 4 and put a dot. And there is a scale factor. It says, what is the scale factor? It is 2. What does that do to the parent function? Does it stretch it or shrink it? Does it make it narrower or wider? So what did we learn when we dilated parabolas? If the absolute value of a was greater than 1, what did it do? So it makes it narrower, and they like to say it's a stretch. Okay. Let's talk about what that's going to look like on our calculator. So let's use our calculator to get some points right now, because I don't really know exactly how this jumps up yet. So I'm going to plug in y equals, I'm going to clear out everything that's on there, and I'm going to plug in 2 math. Then I'm going to right arrow over to num and hit 1 for absolute value. And inside the absolute value bars, I'm going to do x minus 1. I'm going to right arrow out of the absolute value bars, and then I'm going to type in plus 4. Okay, look super carefully and make sure that this equation is plugged in your calculator exactly the way that you see it. So now I'm going to hit second graph. I'm going to generate a table. And we think that the vertex is at 1, 4. So I'm going to go there on my calculator, and I agree. 1, 4 looks really nice. Look at the other points that are near it, though. So 0, 6, 1, 2, 3, 4, 5, 6, and 2, 6. And then 3, 8, and -2. I'm sorry, -1, 8. I think that's all that's going to fit on my graph. Maybe not. 3, 10, and -2, 10. That fits also. Okay. So did this absolute value, don't make it look like a parabola, I almost did that. Did this absolute value become narrower like we said? It kind of got stretched a little bit. Yes, it definitely got narrower. Notice, by the way, it's not going up, right 1, up 1. It's now going right 1, up 2, right 1, up 2, because it's doubled. So that's how that changed, okay? There was a horizontal shift. Where'd it go? It went right 1. And a vertical shift went up, what? Up 4. If you look at my right 1, up 4. Okay, let's try the next one. Okay, this one's a little more challenging than the prior one, which is great. Okay, again, we have d of x, which is equal to the absolute value of x. That's my parent function. What is the vertex of e of x? So let's take a look at e of x. E of x has 0.5, absolute value of x plus 3, minus 2. So the vertex is going to come from over here. Inside lies, so I'm going to write -3. Outside tells the truth, -2. So I'm going to go left 3, 1, 2, 3, down 2, 1, 2, put a dot. And scale factor is 0.5. It's a value that is less than 1, so it's actually going to make it wider or shrink it. Shrink it means it's basically pushing it down from the top. Okay. Describe how it's shifted. So let's actually graph this again. So I think it's wise to use your calculator. So I'm going to do y equals. I'm going to type over wherever I had somewhere I could clear it out again. I'm going to put 0.5 in here. And then I'm going to put in my absolute value. And I'm going to plug in x plus 3. And outside of it, I'm going to plug in -2. And again, double check that what is written here is going to be what's written on in your calculator. You plugged it in correct. So I have 0.5, the absolute value of x plus 3, absolute value bar, and then outside of it, -2. And I'm going to hit second graph. So I'm going to look, and I get some decimals, and that's okay. I'm okay with that. If you only just want to graph the things that aren't decimals, I'm good with that too. We think the vertex is at -3, -2, so I'm going to kind of scroll up or down to get near there. I'm going to try and just graph the whole numbers, or the integers, excuse me. So I'm going to graph, so -3, -2, -1, -1, 1, 0. So that's pretty good. I'm going to go the other way. -5, -1, 1, 2, 3, 4, 5, -1, and -7, 0. And I'm going to label this e of x. Okay, if you look at that, do you see that it definitely got wider? Okay, definitely got wider. Was there a horizontal shift? Absolutely. Inside lies, so it went left 3. Outside tells the truth for the vertical, down 2. All right, let's take a look at the next one. So we're at silver. Okay, so gold, friends, you can go on to the next slide. I'll explain that in a moment. And then we have sum it up. Okay, silver, is there gold? Oh, I changed the order. Okay, so let's go. So silver, and then I'm going to do sum it up, and then I'll do gold. Okay, so let's take a look at silver. For silver, we have f of x equals the absolute value of x, and that is, again, my parent function, which is graphed for you very nicely. And then we're going to graph s of x, which is equal to the absolute value of x plus 3 plus 2. So let's try and do this without our calculator for a minute. So what is the vertex going to be? So if the inside lies, it's going to be negative 3. Outside tells the truth, it's going to be 2. So I'm going to go to negative 3, 2. 1, 2, 3, 1, 2. I'm going to put a dot. There is no dilation, meaning there is no a here. It's still a 1. So it's going to go up 1, right 1, up left 1, right 1, up 1. So it's just going to go kind of in a row here again. And I'm going to call that s of x. Okay, part B says to graph g of x, which is equal to the opposite of s of x. So now I'm going to take s of x, and what happens with this minus sign in front here? Anybody remember? Hopefully you're all saying you're going to reflect it. So I'm going to reflect it over the x-axis. So I'm going to do that. So this is going to be, instead of going to be negative 3, 2, it's going to be negative 3, negative 2. So I'm going to go left 3, down 2. And it's just going to go down now. It's going to be what we would say concave down. And it's still going to look like a V, but an upside down V. So they want to know what the equation of this is. So we're going to write an equation. It's going to be g of x equals, and basically it's going to be the equation that's on the top, the absolute value of x plus 3 plus 2, but now we're flipping it over the x-axis. So we're going to have to distribute that negative 1. So we're going to make negative absolute value of x plus 3. Remember, don't touch what's in here. And then I'm going to write a minus 2. So let's double check that that's actually right. If I think about this, inside lies, outside tells the truth. The vertex would be negative 3, negative 2, which is exactly what we said 2 minutes ago. And it has this lead coefficient of negative 1, which means it is concave down and it's flipped over the x-axis. So this is a great equation. You can always plug it in your calculator and generate a table and see if the points line up with this, or you can even graph it. Okay? All right, so let's do the sum it up. And then we'll move on to gold. Okay. The absolute function is a famous piecewise function. It has two pieces. Below 0, it is negative x, and above 0, it is x. Basically, it's this taking two lines and putting them together. So it says the absolute value of f of x equals absolute value of x equals x. And we're going to write over here if x is greater than 0 and if it's x is less than 0. So this is y equals x, which is a positive slope. 1 over 1 is the slope. Here, if it's less than 0, it's negative x, which just gives it a negative slope. It's heading downward. Okay, again, the absolute value function is decreasing when it's less than 0, increasing when it's greater than 0. All right, so silver friends are going to turn off the video, and then they're going to move on to the homework. Gold, you're with me. Stick with me. I'm going to do gold over here. So let's take a look at the first function. So s of x is the absolute value of x plus 3 plus 2. The vertex is inside lies, outside tells the truth. So it's negative 3, 2. So I'm going to go left 3, 1, 2, 3, up 2. And a still the same. So it's just going to increase. I'm going to draw it in like that. And that is my s of x. I think that's the same as silver, as a matter of fact. I just want to double check. It is. Same exact thing as silver. Okay, it's the part B that's a little different. So this time you have two things going on. Actually, three, really. So we have a -2 times s of negative x. So the negative sign inside the x actually tells me that it's reflecting over the... So this negative sign in here reflects over the y-axis. This negative sign out here reflects over the x-axis. And the 2, there's three things going on here. The 2 means it gets narrower. So lots going on here. So I think the best thing for us to do is to write the equation first, and then we'll go back and talk about what the vertex is and then how to graph it. Okay, so if I'm going to write this equation, first thing I'm going to do is I'm going to write g of x equals. So I'm going to put the -2 in the front. I am also going to do a whole lot of other stuff. Inside the parenthesis, inside the absolute value, I'm going to write -x, and I'm going to write +3 because it's reflecting over that. So it's just the x that changes. But this negative sign on the outside does get distributed to the constant on the right, so it's -2. So that was very challenging to do. Gold worthy for sure. So I'm going to use my calculator, and I'm going to plug this in just to double check that I did this right. So I'm actually going to plug in the top equation in my y1. So in my y1, I'm going to plug in math num1, and I'm going to plug in x plus 3. In the absolute value, I'm going to write arrow out of it and hit +2. Then on the next line, I'm going to write in this next equation. I'm going to write -2 math num1 negative x plus 3 inside the absolute value bars. I'm going to write arrow out of that and write -2. So I'm going to hit second graph. I'm going to look at the red values, the y2, and I'm going to double check to make sure that I'm doing this right. And I'm going to scroll down. I see my vertex. It's at 3, -2. Let's see if that makes sense. So 3, -2. So inside is not lying this time because I have this minus sign here. Actually, that's how that worked because I reflected it. So the inside actually does tell the truth this time since it reflected, and the outside tells the truth. So it's at 3, -2. And let's start graphing this. So let's head to 3, -2. 1, 2, 3, 1, 2. And then let's take a look. So it's at 2, -4. 2, 3, 4. 4, -4. Here. 5, -6. 4, 5, 6. 1, -6. 1, 2, 3, 4, 5, 6. Okay. So it looks like that. And that is my g of x. I probably should have done that in a different color. So let's take a look at what happened here. So this red function here, s of x, it basically flipped over the y-axis. So it kind of like went, this vertex would have gone 1, 2, 3, 1, 2, 3 here, there. It flipped over the x-axis. It then flipped over the y-axis, so then it went down here. And also, it got narrower, so then it doubled with that 2. It's now going down. It's going left 1, down 2, left 1, down 2 again. So it's a whole lot going on here. So this is actually correct. This one here is very confusing. It's very hard to understand that, but you're going to leave it alone when you're rewriting it. But then when you have to think about the vertex, it's actually now lying since it has that minus sign in front of it. So definitely gold worthy. Liked it, liked it, liked it. Probably wouldn't ask anything this hard ever, either on the regions or on a test or a quiz. Okay? Okay, so this ends my lesson. Please stop the video here and you're going to work on your homework.